Okay, you guys can turn to chapter 8 in your books, and we will go over this one. So calculating liquid doses. We're going to look at oral and parenteral liquid doses. These are pretty well just the same. We're going to use dimensional analysis again, and it's just going to be, we're going to be looking at different units. So let's look at the key terms first on page 235. An acto vial system, it says this is a two-section vial divided by a seal holding a pre-measured active ingredient in one section and then a diluent in it in the upper section. So when you puncture them and you mix them, then it automatically mixes the medications for you. An ampule, you guys know what an ampule is. We've looked at that before. It's a little glass container that's sealed and it holds a single dose of medication. You can't continue to use it, and you have to use a filter needle. A depot says long-acting oil-based medications. Elixir, you guys, we've talked about this before, usually contains alcohol and water. Intradermal goes right in under the skin. Intramuscular goes to inside the muscle. Intravenous into the vein. A meniscus is that curved line that you get, like whenever you measure something and you get a curved line. That's a meniscus, and you always measure, remember, at the bottom of that line. Parenteral, of course, are medications that are administered like into the body any other way besides oral, pretty much, or outside the GI tract. Subcutaneous is beneath the skin. It goes into the fatty tissue. Suspension, remember, is a medication that has like particles that are suspended in it. Syrup is usually a sugary type of mixture. A tincture is alcohol-based. And then a vial is just a glass container that has medication. Sometimes they're plastic, has a medication in it. Okay, so let's go on. On 243 is where this starts. So we're going to look at all different things. We're going to look at how to figure out how to get a specific dose of a medicine. If the doctor just gives milligrams and we've got a dosage going on, how much do we give, and so forth. So this is pretty common as well as far as pharmacy math and nursing math goes. Look at the tech alert. It says when it's necessary to compute medication doses and equivalencies, the equivalent should be no more than 10% above or below the amount of the prescribed dose. So keep that in mind, just like we did with the solid doses. It says please be aware that some medications require that rounding be within a much lower percentage of variation. This is due to the narrow range. For example, if you have some medicines are they can be toxic even with just a little bitty bit more, so you have to be really careful with that. So let's look at oral liquid meds first. You've got some different mechanisms or cups, ways to give medication on here. You will have to draw in some of these whenever you get to the post-test. So if a dropper comes with something, you need to make sure and give it. The best thing to use typically is a syringe, an oral syringe. An oral syringe doesn't have the same tip on it that like an IM or IV syringe has. It doesn't have that little kind of a threaded tip on it. Usually volume is what you're trying to find out, is the unknown part when we're looking at these medications. So you can use ratio and proportion, but again, I'm going to use dimensional analysis. So let's go ahead and do some excuse me, let's go ahead and do some of the practice ones. Practice problem A on page 250. Let's go ahead and look at this. All right, so ordered medication. So what's ordered is decloxacillin suspension, 100 milligrams, PO, BID. That's our order. Okay, 100 milligrams, PO, BID. Now, so let's look at the label now, and it is given, it says there's 62.5 milligrams per 5 milliliters. So that's what's available, 62.5 milligrams per 5 milliliters. That's what's available. So that's how we've already interpreted our order. So now we need to know how much are we going to give in a dose, okay? So we want to know how much, so how many milliliters, that's what we're trying to figure out, do we need to give. So same thing that we've done before. I'm going to put my milliliters over here. Okay, I know there's 5 milliliters well, there's 62.5 milligrams in 5 milliliters. I'm going to put my milliliters on top so I get my same unit over here. And I know that the dose is 100 milligrams by mouth. So my milligrams all cancel each other out. And then I can just multiply and divide like you see on here. Oh, sorry, make everybody seasick here. Zoom in as far as I can. So I get 8 milliliters. So that's going to be our dose. So same way we did with the tablets, we're just using different units here than what we were using. Okay, let's do a couple more. Let's do number let's do number 6. This one's pretty, maybe too easy, but number 6, prescribed ranitidine syrup. Number 6 is on page 254, I'm sorry. 150 milligrams BID Q 12 hours. So our order then we know is for 150 milligrams. And what we have available, look at the label there, we have 15 milligrams per milliliter. So we're wanting to know milliliters because we want to know the dosage. I'm going to put my milliliters over here on the end. Okay, and every 1 milliliter we have 15 milligrams. And then our dose is 150 milligrams. Cross out my milligrams, I'm going to get 10. So 10 milliliters. And then what you would do to answer this is temperature order and then the volume of medication to be given. And then you have to draw it out on that cup there. Now let's do number 8. This one gets a little bit hairier, a little bit more to answer with it. All right, Vibramycin, oral suspension, 150 milligrams stat, and they need it right now, and then 75 milligrams every 12 hours. So that's our interpretation of the order. The initial volume of medication to be given with each initial dose in the metric system. So we're looking for milliliters. So the initial dose is 150 milligrams right now. That's our order. 150 milligrams. What we have available, look on the packaging, it says there's 50 milligrams per 5 milliliters. So in every 5 milliliters of this medicine, there's 50 milligrams of the active part of it. All right, so 150 milligrams now. So how much do they need for that now? They're still wanting to know milliliters. Milliliters over here. I know there's 5 milliliters and there's 50 milligrams in that. And that there's 150 milligrams is our dose. Cancel out my milligrams. I multiply this. I'm going to get 15 milliliters. So that's how much they need right now. Now it says, the next question says, the initial volume of medication to be given with each initial dose in household measurements. Well, 15 milliliters. Okay, so now we need to translate 15 milliliters into household, which is like your teaspoons and your tablespoons. So if you go back to your conversion chart, this one actually is going to be easy. You have to work it out. You go back to your conversion chart on go back to page 141. It's on here, or it should be. So look, you got 15 milliliters equals 1 tablespoon. It's on page 141. 15 milliliters is 1 tablespoon. So that means that's what the answer is for that question. In household measurements, they need to take 1 tablespoon of this medication. Now it says subsequent volume with each subsequent dose to be given in the metric system. Okay, so now let's go back to our order. It's wanting to know how much per dose do they need in the rest of it. Okay, so our order then is 75 milligrams every 12 hours. And what we have available again is 50 milligrams per 5 milliliters. Okay, so now we need to figure out this dose. Same idea. Dimensional analysis, got our milliliters on the end, but this time we have a little bit different dose going on. 75 milligrams. Cancel out our milligrams, and then we can multiply this. I'm just going to do it real fast to make sure. 7.5 milliliters is what we're going to get. Oh, yeah. Okay, so 7.5 milliliters is what they would need. And then to give that in household measurements, okay, let's think that through for a second. We want to change 7.5 milliliters into teaspoons this time because we know it's smaller. So we can do half a tablespoon because we know that was 15, or we can fix it into teaspoons. So 7.5 milliliters is the info I have. If I want it in teaspoons, I know that there's 5 milliliters equals 1 teaspoon. I want to know it in teaspoons. 1 teaspoon is 5 milliliters, and we have 7.5 milliliters. Okay, so you divide that out, you're going to get 1.5. So 1.5 teaspoons would be that subsequent dose in household measurements. Okay, so that's it. That's this dimensional analysis, and here you're just going to have to use maybe some different conversions than what we have been using. Look at number 20 real quick on page 261. So what's prescribed is Lorabid oral suspension 50 milligrams twice a day. Okay, so our order is for 50 milligrams BID. Okay, and now it says which bottle of medication would be used to prepare this medication for a more accurate administration. Okay, so look, we've got 100 milligrams per 5 milliliters, and we've got 200 milligrams per 5 milliliters. Okay, it's going to be easiest to fix this medication for someone if we've got a little bit larger dose. Like in this case, it's going to be easier with that 100 milligrams per 5 mLs. Okay, because that's basically going to give us 2.5 milliliters. If we did the other one, it's going to make us give 1.25, which is going to be kind of harder to measure accurately. So A is the best option here, definitely. So now we know what's available is 100 milligrams per 5 milliliters. You just always want to go with the one that's going to be easiest to measure, that they're going to be able to do most accurately, because you're going to see some of these questions too. A volume of medication per dose from the bottle selected in the metric system. So how many milliliters then do they need? Let's set up our dimensional analysis. It's going to be 2.5. 2.5 milliliters. Okay, I already worked that one out, didn't I? Volume of medication for the above dose in the household measurement, we already know teaspoons is 5 milliliters, so 2.5 milliliters is half a teaspoon, so that's the answer to that one. And then on the other one, like we said, if you work this out again and you use the other bottle of medication, okay, you're going to work out the same thing, but you're going to get a little bit less here. So 5 divided by 4 is 1.25 milliliters. Okay? So there's that. Pretty simple. Same thing that we've been doing. Okay, 263. Look at the tech alerts on this one. 262. Of course, any parental medicines have to be sterile. Once they have been injected, you can't get it back, so you have to be really, really careful with these. Some syringes, it says, may have minimum markings. If these syringes are used, care must be taken to read the correct measurements. I've never seen one. I'm sure they're out there. Typically, all the syringes are in milliliters. Look at this tech alert. It says, if the answer to a dose calculation does not agree with the anticipated answer, based on the amount of medication prescribed and the medication on hand, always redo it. Like I said, if it's like really off and you're like, that sounds so weird, redo your calculation. 265, it says, look at this tech alert. It says single dose vials and ampules contain a little bit extra volume of medication, so measuring the amount of medication for administration accurately is important. It may have a little extra, so always measure with your syringe. All right, tech alert. The bottom one says when calculating injectables, other than intravenous use, you should arrive at an answer that is within the above limits. If not, question the results again. Okay, look at these on 266. It's just asking you to figure out the amount in the syringe. It's just practice reading a syringe. Okay, so depending on how big the syringe is what's going to determine what those smaller marks are. Like the one on number 1, each mark is 1/10 of a milliliter. Okay, so that 1 is 1 milliliter, 2 milliliters, and so forth. So if you're supposed to give 2.1 milliliters, this is a great syringe to use. So that's another way that you're going to determine which one to use. And it'll offer you different ones, and you need to be able to pick out the best one, the one that you can get the most accurate answer for. Typically, the smaller your amount, then the smaller syringe. So, for example, if you're supposed to give 1.5 milliliters of medicine, you don't want to use a 5 milliliter syringe. You'd much rather use a 3 milliliter syringe. Okay, so you can look at those. All right, and then let's look at practice problems C for a minute. Let's look at number 3 there. Prescribe tobramycin 60 milligrams IM every 8 hours. Every 8 hours. We've already interpreted the order of volume of medication to be given in a dose. So let's figure out how much we got to give. Let's look at this label. It's kind of small. Okay, it says that there are 80 milligrams per 2 milliliters. That's what's available. 80 milligrams in every 2 milliliters of medication. And our order is for 60 milligrams. So we need to know how much is supposed to be given in a dose. We want to know milliliters is what we're looking for. So put our milliliters over here. We know there's 2 milliliters for every 80 milligrams of med, and 60 milligrams is what we need. So cancel out your milligrams. And we're going to get, is it 1.3? I'm sorry, 1.5. What am I doing? Thank you. It's been a long day. Okay, so 1.5 milliliters then is, that is not right. Okay, it is right. I don't know. It's been a long, long day. I guess my brain's going crazy. So 1.5 milliliters then is the volume of our dose. So if you look at these 2 syringes here on number 3, if you pick that first syringe, see how it says it's just 1 milliliter syringe? You're not going to be able to fit all of your medicine into one syringe, and you're going to have to give them 2 shots, and then they're going to be mad. Okay, but the second syringe, that 3 milliliter syringe, can fit all of this medicine in it. So that one is your best choice there. Okay. Let's look at number 4. Prescribed vitamin B12, 0.2 milligrams IM every week. 0.2 milligrams. We're given this IM, and look at the medication available, there's 100 micrograms per milliliter. 100 micrograms per milliliter. So we need to know the volume. We want to know milliliters. That's what we're trying to figure out. Now, I know I've got every 1 milliliter, there's 100 micrograms of medication. Now, what I don't have up here yet is my conversion. So I know there's 100 micrograms in every milligram, right? I do my King Henry. So there's 100 micrograms in every milligram. That's our metric system. So if I do 100 micrograms here in every milligram, that's my unit. Okay, that crosses those units out. Now I have my dose, my medication, 0.2 milligrams. Cross out my milligrams again. Now I can, my mom's wondering where I am. It's kind of late today. Pick up the kids. Okay. Oh, well, this was easy, wasn't it? 0.2 milliliters. I don't know why I did that on the calculator. So, it says, can this vial fulfill the order? I just lost my train of thought. I'm sorry. 0.2 milliliters. Yes, I mean, you can use this. I don't know why you wouldn't be able to use this medicine to fill it, but you'd have to get a really small syringe if you know that. This probably wouldn't be your best one. Okay. Let's go on. I think that's it. Let's do one more of these. Okay, I want to do one more. Let's do excuse me. Let's do number 20 on page 277. All right, it says prescribe the medication ordered as Tagamet, 75 milligrams IM. Okay, Q 6 hours. So volume of medication to be given in a single dose. So let's look at what we have available. Notice it says on this label, it says there's 2 milliliters, there's 300 milligrams in every 2 milliliters. 300 milligrams in every 2 milliliters, and we're wanting to know milliliters so we can give this med. Let's do our dimensional analysis here. 2 milliliters in every for every 300 milligrams, and our dose is 75 milligrams. Now, milligrams cancel out. I end up with milliliters left over, so I know I've got the right conversion units. Okay. Oh, my phone quitting on me. Oh, there it goes. Oh, I could have figured this one out in my head too. So half, we got 1/2 of a milliliter. So that's our dose, our single dose. Now let's look at these syringes. Okay, so you got 3 different ones, and really, you could pick either of the first 2, and it would probably be fine. But if it's me, and I already know I've got 0.5, the first one is really our best option. It's going to allow for the most accuracy. So the first one is the one I would pick. The second one would be fine. You can see clearly where 1/2 of a milliliter is. The third one, not so much. It wouldn't be the best one to pick because it's just, it's too hard to figure out exactly where the dosage would be. Okay, so that is that. That's chapter 8. You guys can, why don't we do the same thing on this? You guys just do the odd ones. That'll be 10 questions for you guys to practice on. And you can get that done. That's it.